A ball is projected with a velocity of 20 meters per second vertically upwards. Find the distance travelled and the displacement in the first 3 seconds. Use g equal to 10 meters per second square. The key idea to be learned through this problem is how is distance different from displacement, and when they are same and when they are not. This question provides a good scenario to understand the concept of displacement and distance. First, we will see the displacement of this ball with respect to time. Let's see the motion of the ball. Notice its displacement. Well, that was familiar. We should be able to draw its graph now. Remember, displacement is change in position of the ball from initial position, that is the ground. Movement in upward direction relative to ground is positive. So as the ball moves up, its displacement increases from 0. Look at the slope of this graph when the motion just starts. Its slope denotes its velocity. So if the ball is moving up, what should happen to the slope as the ball moves further? It should decrease. And why? Because the velocity is decreasing as we go up. Hence, the graph will look like this. At the highest point, the slope, that is velocity, becomes 0. And then velocity and slope becomes negative. Finally, the displacement becomes 0 when it hits the ground. Displacement increased till the ball was moving up, and when it starts coming down, the displacement from initial position starts decreasing. That was for displacement. But what about distance? We know distance is the actual distance covered by the ball. Let's look at the motion of the ball again and try to see the distance it travels as it moves. Remember, distance is always positive and never decreases and always increases with time. Now if we draw its graph, we see for the first half the distance travelled is same as displacement. But in the next half, though displacement has been coming down, distance continues to increase. Why is it so? Remember, like slope of displacement versus time is velocity, similarly slope of distance versus time is speed. And like distance, speed is never negative. So while the velocity, that is slope of the displacement, is negative, speed, that is slope of the distance, remains positive. But they are having same magnitude. Hence the complete graph will be this. The final conclusion we can draw from this is distance and displacement remain same until the velocity changes its sign. For the given question, the point when it reaches the highest point, which can be obtained by v equal to u minus gt, we can find the time when v becomes 0, that is the highest point when the velocity changes its direction. It comes out to be 2 seconds. So till 2 seconds the displacement and distance are the same, but after 2 seconds they become different. To find displacement, we will use the equation s is equal to ut minus half gt square and put t equal to 3 seconds to get displacement. This comes out to be 15 meters. To find distance, we will have to find these two distances and sum them up. This distance, which is maximum height reached by the ball, can be found by the equation v square is equal to u square minus 2gs, putting v as 0. This comes out to be 20 meters. Hence, this distance is 20 minus 15, that is 5 meters. So, distance travelled is 20 plus 5, that is 25 meters. Last point to be noted in this question is, in the first part of the journey, as we already know, displacement is same as distance. But for the second part, that is between 2 and 3 seconds, the magnitude distance and displacement are same, just one of them is negative. Hence, distance is 20 plus 5, whereas displacement is 20 minus 5.